Hello everyone, this is Manish from Skillable India, and in this particular session of GD&T, Geometric Dimensioning and Tolerancing, this is the continuation video or the session of the rule number 1. Okay, so in rule number 1, we have already understand that what are the requirements to fulfill if we want to obey the rule number 1. Okay, so in this session, I'm going to tell you that how you can override rule 1 and what are the exemptions in the rule 1 and how you can verify with the rule 1. Okay. So, okay. So rule number 1 and you can see over here. Okay. So first we will know about the exemptions. Okay. So first of all, we rule number 1 does not apply to the non-rigid part. We call them, this is the exemption 1. Okay, so rule number 1 does not apply to non-rigid part. The non-rigid parts like o-rings, belts, gaskets, and other non-rigid parts that are flexible and do not maintain their nominal shape in the free state. Okay, so in the free state, if the part do not maintain their nominal shape, okay, like rubber. Okay, so these type of material which are made up of rubber, okay, so they do not maintain their nominal shape. Okay, so they do not come under the rule 1. Okay, so they are exempts from the rule 1. Okay, now the second thing which are exempted from rule 1 is it does not apply to the stock sizes. Okay, in the starting of this course, I have already told you what are stock sizes. Okay, so in stock sizes, there are sizes which are the standards which are governed by the government entity like BIS in India. Okay, Bureau of Indian Standard controls these sizes, these standard shapes. Okay, so in this, bar stocks is there, tubing is there, sheet metal sheets are there, structural shape like I section, C sections are there. Okay, so these in this example you can see that these structures, these shapes, structural shapes does not obey the rule 1 because they are exempts from the rule 1. Okay, so these are the two exemptions in which we don't follow the rule 1. Okay, now we will understand how to override rule 1. Okay, so rule 1 automatically applies to all the individual feature of size. First of all, this line is very important that rule 1 is a default condition. Okay, so on each and every engineering drawing. Okay, so this is a default condition. So on each and every engineering drawing, it automatically applies to all individual regular feature of size. Okay, so again and again, I have already told you what is a regular feature of size, irregular feature of size. So this does applies to the regular feature of size onto the engineering drawing. Okay, in some application, producing a part with perfect form at MMC may not be required, and if given will increase the cost of manufacturing. Okay, so as we already know that rule 1 is also named as perfect form at MMC. Okay, so sometimes we do not require the perfect form of the part at MMC. Okay, because it will increase the cost of the part, it will increase the manufacturing cost of the part if we will need the perfect form. Okay, so we should provide some tolerances to it. Okay, so first of all, one by one we will understand this. So then it becomes essential to override rule 1. Okay, so this can be done in 3 ways. So the rule 1 can be override in 3 ways. One by one we will understand. uh, Okay, first one is applying straightness to the size dimension of a cylindrical regular feature of size. Okay, if we apply the straightness tolerance to a size dimension on a cylindrical regular feature of size, so we can apply override rule 1. We will know in detail this. Okay, in detailed manner we will know this. Applying a flatness tolerance to a size dimension on a planar regular feature of size, specifying independency symbol. Okay, so there is one independency symbol which is like this, specifying independency symbol to a regular feature of size dimension. Okay, so these are the three ways to override rule 1. Okay, one by one we will understand this. Okay, so in this case, you can see that applying straightness to the size dimension of a regular feature of size. In this, you can see that this is size dimension, and we have provided the geometric tolerance straightness with 0.5 mm of tolerance over here. So here the straightness tolerance is applied to the size dimension of a regular feature of size. Okay, so in this case, the axis of the part, this is the axis. You can see this axis. This is the dia. Okay, so in this case, the axis of the part is permitted to have the straightness variation. Okay, when the size dimension is at MMC. When the size dimension is manufactured at MMC, we still have the straightness variation of 0.5 mm. Okay, so when the part is manufactured at a maximum material condition, which is 10.5. Okay, so each and every position, so this is here in this case 10.5 is the MMC condition. Let's, in this case, if we provide this, okay, in this case, when we provide the straightness tolerance to the cylindrical part, to this cylindrical shaft, okay, so when the part is manufactured at its maximum material condition or at MMC, at each and every point, this is dia 10.5. Okay, so when the part is manufactured, still in this case we have the tolerance of 0.5 mm. Okay, so this size, this overall size can have the maximum variation of 0.5 mm. Okay, so this distance can be 0.5 mm by applying the straightness tolerance. Okay, so this is how we can override rule 1. Okay, because sometimes why we should increase the cost in manufacturing. Okay, so at this time we provide this straightness tolerance, that even if the part is manufactured at its maximum material condition and it is having some variation in its axis, let's say the maximum variation it can have is the tolerance which we have given in the straightness tolerance, which is in this case which is 0.5. so this is the geometric tolerance value which we have provided in this example. Okay, so maximum variation this part can have is of 0.5 mm even if it is manufactured at maximum material condition. So this is how we can override rule number 1. Okay, so this is similar to the this is the second way you can override rule number 1. Okay, this is similar to the first one only. Similarly, when we apply the flatness, okay, to a tolerance to a regular feature of size, to a size dimension of a planar regular feature of size, okay, so in this case you can see that whenever we are applying this flatness, so this is the symbol of flatness. So in this case also, if the part is manufactured at, let's say, at maximum material condition, so if we will find out for this part, what will be the maximum material condition is 10.5. Okay, so 10.5 will be the maximum material condition for this part. So if we see the flatness, so it is having the 0.5 mm of variation. So maximum variation again in this case also. So this variation from here to here, we can have 0.5 mm, even if the part is manufactured at its maximum material condition. Because there are some conditions in the rule 1 which we have understand in the previous session, that there are some condition needs to be fulfilled for the rule 1. Okay, so if we are overriding rule 1 to reduce the cost of the part. Okay, finally, if we specifying the independency symbol to a regular feature of size, so in this case, this I symbol, this is the symbol, this is the symbol for independency. Okay, so this is the symbol for independency. We can override if we apply independency symbol 10 plus minus 0.5 to a regular feature of size. It means we are overriding rule number 1. Okay, so whenever this I symbol, whenever this modifier This is the independency modifier. Whenever we use this modifier we used along with the size dimension, it tells that that this particular size dimension of a regular feature of size does not obeys rule 1. Okay, so whenever we use the I modifier, it means this dimension, this size dimension does not obey the rule 1. Okay, hence we can override this rule number 1. Okay, so these are the three ways in which you can override rule 1 of geometric dimensioning and tolerancing. Okay, so we have some limitations in the rule number 1. Rule number 1 does not control the location, orientation or alignment between the feature of size. Okay, so in this case, in this example, you can see that this is the feature of size 42 plus minus 1. Okay, and these are the feature of sizes. Okay, and for 32 plus minus 0 point plus minus 1. Okay, so this is the feature of size. Okay, so in this case, in this rule's limitation, in this way, it is going to tell you that these size feature of size does not control the location, orientation or alignment between the feature of size. Okay, in this case you can see that this surface and this surface is having a 90-degree angle into the drawing. Okay, and in this from side view, this also having the C. Okay, this is denoted as B. This axis of this hole which is coaxial with the one another, this is one hole. Okay, so this and this hole both are coaxial in nature in this drawing. Okay, so this is denoted by A, and other sizes are also denoted by D and E. Okay, so these are the diameter size. So in this example you can see that unless otherwise specified, interpret as per ASME by 14.5 2009. So this is the GSME standard, all angles plus minus 5 degree. Okay, now after manufacturing this part, after manufacturing this part does not, this part manufactured like this. Okay, so this is not at right angle. Okay, this is also not at right angle. These holes are not coaxial with one another. Okay, so you can see over here that one hole is not coaxial with one another. Still this part will obey rule 1. Okay, so for obeying rule number 1 we have only some of the criteria. Okay, what are these criteria we have? We will verify with the rule 1 this part. Okay, so this part just have to follow some of the verifications that so this part does not control the angle between these features, the coaxiality between these holes. It will only control the rule number. If we want to, it verifies the rule number 1, so it has to verify the two methods. So let's say what are the verification. So in this particular limitations we have understood that this does not control the location, not control the orientation, not control the alignment. Okay, so if we want to verify, so this is the verification of the rule number 1. Okay, so first of all, if we have to verify the rule number 1, first of all we have to check that the actual local size should be within the limit of size. Okay, so at each and every cross section, in this case it is dia 10 plus minus 2. Okay, so the maximum material condition will be dia 12 and the LMC least material condition will be dia 8. Okay, so in this case it is saying that the actual local size should be within the limit. Okay, so this is the limit, this is the limits. If all the sizes, let's say at all points this size is within the limit, let's say this is having 10, 11, 12, 8, so it can vary from 8 to 12 anywhere, but it should be within the limit of size. So this is how the first condition satisfied. So first condition is satisfied. Okay, so we have verified the first condition. Now, the second condition of the verification of rule 1 is that the MMC and the envelope rule. Okay, so the part should enter into the envelope. So envelope is of maximum material condition. So in this case, dia 12 is the maximum material condition. So the maximum size of this envelope, the part should enter is 12 mm. Okay, so this is the MMC rule. Okay, so if the part is manufactured at maximum material condition, let's say part is manufactured at this part is manufactured at maximum material condition from here to here. Okay, let's say this is of 10 mm and 2 mm of variation. So maximum 12. So if the part is entered into the envelope, so the condition 2 is also satisfied. It means this obeys rule 1. Okay, so these are the two verifications which we have to do in verifying the rule 1. And rule 1 is a default condition, so it is applied on all the engineering drawings. Okay, so this is all about rule number 1. In the next discussion, in the next session, we are going to discuss about rule 2. Thank you all of you.